Good morning, friends. Happy New Year. Thank you for joining us on the first session of Fired Heater Design Training Seminar or webinar, as we call it. Uh, I hope all of you are staying safe, and I hope this Omicron is taken care in the next few weeks, and then we can all live our normal life. So, why are we doing this webinar? Or why are we talking about fired heater training? We have been in the business of revamping fired heaters for almost 25 years now. And we felt a need that the current procurement procedure, which is followed in US and elsewhere, does not take care of interest of the end users. And most of the time, the end users end up with a heater which requires fixing maybe after 2 years, after 3 years, and they find that they have to make changes. Now, heaters is a very expensive equipment, and anytime you want to make a fix, you have to take a shutdown and you have to spend millions of dollars. So we thought that if we can do these webinars and empower our attendees and our end users and our clients about the critical design parameters, what all goes into fire heater design. The hope is that next time, whenever they have an opportunity to buy a new heater or fix a new heater, they will be a lot better prepared, and they will be able to get more value for their money. So that is the background why we have started this design training webinars. And we are going to be doing this over 12 sessions, one every month. And the reason for that is that fire heater design is very complicated. I'm not trying to scare you off, but it is complicated. And as you know, the heater design is an empirical process. What we do is we design or make a heater and then we check whether it will serve the purpose, whether uh, it will meet all the required parameters, whether it is radiant flux, whether it is duty. So it's a kind of an iterative process. And heater design, two things I want to tell you. I think I might have told you in my previous webinars is fired heater industry or the refining industry is about 120 years old. And the heaters which were built in the beginning were mostly based on the convective heat transfer. And they would last maybe one run, 1 week, and then they had to be shut down and cleaned. And then, they were kind of a batch process. The initial fired heaters in the industry were a batch process, and only later on they changed it to pipe stills. And it wasn't until 1940s that they realized that they need to make use of the radiant heat transfer. And there were two very brilliant engineers or scientists by the name of Lobo and Evans who wrote this paper about designing fired heaters. And the good news is, even today, all the heaters which are designed by all the vendors are still designed using the same correlations. There have been a lot of changes in fired heaters. And I think maybe for the next 20, 25 years, there will be more changes as we talk about greenhouse gas emissions, and people are talking of firing hydrogen in the heaters, or maybe changing the heaters to electrical heaters. So there is going to be a lot more changes coming. I mean, world has never been static. It's been always dynamic. Industry is always changing. So that would be, I think, procedure will be evolving, or the design procedure will be changing. But that's the name of the game, or how the life is. One big change which has taken place in the last 20, 25 years, or maybe 30 years, is the reliability. There has been a lot more stress on the reliability of the heaters. We want our heaters to be running all the time. We don't want to shut down our heaters. This is very different scenario from 50 years ago, when people would religiously shut down the heater every year, clean it up, and then start it again, or every 2 years. But now we want our heaters to run 8 years or 5 years, and then that requires a different approach to design. Similarly, the burners have changed drastically in the last 50 years. We have moved from premix burners to ultra low NOx burners, which have 4 times the flame height. So again, the designs have to be very different. So as we go along in our webinar, we will be discussing and talking about all these issues. So what are we going to be doing today is talk a little bit about introduction, talk about typical heater procurement procedure, and then we will talk about a real fired heater design problem. We will take a real fired heater design, and I will talk to you, and we will talk about the major design parameters, and then we will move ahead, with that design, how we come up with the design of the heater. Feel free to send me any questions anytime if you have. And I really want to thank all of you for sending so many questions in advance. I think I feel very blessed that you have shared the problems in fired heaters with us and our team. And they will be working on all your issues, and will be contacting you, if needed. But without further this thing, let's just talk about how the heaters are being procured today in most part of US and the world. So typically when you have a project, most of the projects are carried out by big EPCs, engineering companies, and they sometimes hire licensors, and they come out with a front-end engineering design package, feed typically, as it is known in the industry. And that is given to the EPC, the successful EPC, and they are asked to develop a plus minus 10% cost estimate. So the EPCs take the data sheets which are developed by the licensors or the client, or by EPC themselves, and they go out to the heater vendors and get the preliminary cost estimates. And these cost estimates, and then they are taken by the EPCs to develop the project estimate. And once the project is approved, EPCs take those proposals, firm up their inquiries, and send the firm inquiries back to the heater vendors. And the heater vendors, they submit their most competitive proposal, because most of the jobs are decided on the price. And EPCs, basically what they do is they make a technical bid comparison, select the lowest two vendors, and then have discussions with the lowest two, lowest three vendors, and then come out with uh, a company who says we will be able to meet all your requirements, and they give them the purchase order. So what happens is, during all this time, the critical design parameters somehow get neglected. They take a back seat. Things like reliability, you know, we are not talking of reliability, we are not talking of maintenance, we are not talking of, so many critical parameters. And and the most stress is on comparing one offer against the other. So typically what they're doing is putting one vendor against the other and trying to make sure that both vendors are at par. But that does not mean that you are getting the best design, actually, because best cannot be cheapest. There is no way, uh, if you're buying a TV, Samsung TV is going to be the cheapest. So you have to kind of uh, make a compromise on the heaters, and then you end up paying recurring maintenance cost, which are much more as compared to the initial cost, what you save on the initial cost. So our approach is, get the design right the first time. Do it once, do it right. That's our approach. And we can help you there. We can help you. The way we do it is, we give you the process design, and then you can take it to any EPC or any heater company, and it will ensure that you don't get a cheap heater. You get the best heater for your money, actually. We did a design for crude and vacuum unit for Citco, and they had said we want 8 years run length. And we were able to show them that the heaters ran for 8 years. So that's the type of performance you can expect from us. So what I feel is, the procurement procedure needs improvement, and that's where we come in. So let me talk about our company, Furnace Improvements. Uh, they We started in 1996. We have two offices, Sugarland, Texas, and then we have a main office in Noida. Now, basically, the main office is where all the activities are taking care. Our mission has been improving the performance of existing fired heaters. That's what we do for living. Basically, take your heater, improve their run length, improve the capacity, improve the efficiency, reduce emissions. And our model has been working directly with end users and owners, as we call it. It's a model which is like a patient-doctor's relationship. We look at the patient and then we prescribe the medicine. Uh, and we have a very unique value-added approach, and it is somewhat based on contrarian approach. We challenge what has been done and why it has been done. So we have a kind of a uh, getting back to the basics and looking at the heater. If you give us a heater, we will look at the basics and see what is gone wrong in that heater. And that is on that basis we have developed 3 patented technologies: inclined firing, split flow, smart spec damper. So that's basically our uh, uh, approach to fired heaters. Uh, and as I said, our approach is do it once, do it right. Because of time difference, we are able to do the work around the clock, and we are able to keep schedules. We can do work schedules on a very, very fast this thing. Uh, the presentation today has been prepared by our team in Noida, and I really want to thank them. They are the real heroes who have uh, spent time and prepared this presentation. I'm just the face for the making this webinar today. So as far as our capabilities are concerned, our forte is process engineering. We have in in-house CFD modeling capabilities. I think maybe we are the only heater company with in-house CFD modeling company CFD modeling capability. We do our mechanical engineering, structural design. We have SolidWorks for 3D modeling, and we can do your project from start to finish, all the way from design to erection. We can take the project. This is a list of our clients. Most of them are in US, and I want to thank all of them for sticking with us and giving us business for the last 25 years. So we really thank all our clients for giving us business and trusting us. Okay, so much for the furnace improvements part. Let's move on to the fired heater design. So we want to go into details, and that's one reason I decided to break this webinar into 12 parts. We will start with the major design parameters today. Then next month, we will have it once every month, and that will give us time to prepare. It will also give you time to absorb and send us questions. You will need to register every time. So we could not find a way that we could register you for all the webinars. So you will have to register it. So the next month, we will talk about combustion and efficiency calculations. Efficiency has always been on the back burner in the US, but now with the greenhouse gas emissions, I think efficiency will play a very important role. And we are already seeing many of our clients are asking us to put their air preheater system back online, actually, which had been bypassed for last 20 years. So efficiency is an important thing. Then in the third and fourth sessions, we will talk about radiant section. We realized radiant section is the key to the fired heater design, or the major component in the fired heater is the radiant section. So we will take 2 sessions in doing that. Move on to the burners. I hope we will be able to finish it. Then we will talk about convection section. Uh, move on to stack sizing and draft calculation. Stacks, we are seeing taller and taller stacks, especially in India, 60 meters, 65 meters, 80 meters. So I think refineries and governments are taking cognizance of pollution And that's a good thing. Higher, the taller the stack, the lower will be the ground level concentration. Air pre-heating systems are going to make a big comeback because that's one of the most effective way of improving efficiency. So we will talk about air pre-heating systems. We will talk about refractory and heat loss calculations. We'll talk about waste heat recovery systems, also like steam generation, tube thickness calculations. And in the last session, we will summarize everything what we have discussed and learned, and leading to better heater specifications. So that's my plan actually. It may change as we start making the material, preparing the material and getting your input, but that's what uh, how we want to conduct this webinar. So, and I want this webinar to be tailored to your needs. So if you need anything, if you want me to clarify anything, please feel free, Uh, I believe most of you know me actually. I mean, I think I don't need an introduction at this stage of my life. You know, I'm a chemical engineer. For those of you who don't know me, I'm a chemical engineer from IIT Kanpur, passed out in 1974. Uh, and I've been working on fired heaters for almost 45 years. My plan is to work for another 5 years and complete, at least up to 2024. Uh, I have been a member of API, ASCHE, ASME. For the past 25 years, I've been taking care of furnace improvements. This is my third child, as my family says. Furnace improvements is my third child. I've been taking care of it. It's almost 25 years old now. Uh, Thanks to all the team members who have contributed to this webinar today. I mean, they have been working very, very hard. My process team, SolidWorks team, mechanical team, they have all contributed and prepared all these nice sketches and models you will see are a result of their hard work. So let's talk about fired heaters. Uh, Given a choice, process engineers don't want to put any fired heaters. They think if they can do it with a heat exchanger, that would be much, much easier for them. But the temperature what we need in refining and petrochemical industries can only be achieved by fired heaters. We are talking of 900 degrees in coker heater, 1400, 1500 degrees in steam methane reformer, 1600 degrees foreign heat in uh, ethylene cracker. So these temperatures you cannot get anywhere else actually. So we have no choice but to go for fired heaters. Fired heaters have two major heat transfer sections. We will talk about them in a lot more detail. Radiant section is a major heat transfer section where approximately about 60 to 80%, let's say approximately 70% of the heat transfer takes place in the radiant section, and 30% of the heat transfer takes place in the convection section. These are the two major areas where the heat transfer takes place. And there are numbers and numbers of designs available. We will all cover those designs as we go on. But let's talk about major components in fired heaters. API says there are 21 components, and I think our team has shown a lot of components over here. But as I said, radiant section, convection section, and the stack. These are the three major components. And then the burners, most important component from the operation standpoint or from the process engineer standpoint, even though burners in terms of expense are very little. They only have 3 to 5%, they cost only 3 to 5% of the total heater cost, but uh, that's basically negligible. But in terms of operation, burners and stack dampers are two very important components in fired heater. Here in this picture, we are showing a horizontal tube cabin heater and a vertical cylindrical heater. We will talk more about it a little bit later in the presentation. So let's talk about types of heating. What type of heating we are looking at. Most of the time in fired heaters, we either have fluids which are hydrocarbons or steam. There could be some other things also, but we are talking mostly hydrocarbons or this steam. And these fluids could be in liquid phase or in gaseous phase. So there are two types of heaters. There are one heater in which there is no phase change taking place. That means liquid is going in, liquid is coming out. Or vapor is going in and vapor is coming out. The example of liquid going in, liquid coming out is a hot oil heater. Vapor going in, vapor coming out. We can talk about the catalytic reformer heaters. Those are the ones. Uh, Most of the heaters in the refining industry are of reboiler nature. That means liquid going in, liquid plus vapor coming out. And the examples there are plenty: crude heater, vacuum heater, so many hydrocracker heaters. So tons and tons of heaters. But those are the third type of heating I'm not talking about here are where there is a heating and reaction taking place. So that means there is an endothermic reaction taking place and the heat is used for carrying out that endothermic reaction. Steam methane reformers, cracking heaters for making ethylene, and to some extent maybe coker heater falls in that category. But most of the time we're talking of simple heaters, and this is what we do for as far as the classification is concerned. So let's talk about how fired heaters are designed. The fired heaters are always custom designed, and each one is tailor made to meet the customer's requirement, site requirement, process requirement. So there are so many things. So very rarely will you see a repeat of fired heaters. I want to tell you, I think 30 years ago, I used to work for a heater company, and they got an order from Mexico for 2 heaters. And we thought we will be able to uh, provide identical equipment. But once we received the data sheets, it turned out that one of the heaters was to be located in Tula, Mexico. And Tula is at about 6,000 feet elevation. The other was at a sea level. So just the sea elevation of the site makes a big difference in the heater design, actually. So even though they both had the same parameters, the heat duty and everything else, same fuel, same type of fuel, but their design was different. So let's talk about the most important parameter for fired heaters. And most of the heaters are defined in terms of heat absorption capacity. We measure heat absorption in million BTUs per hour. If we are talking of metric units, then it's going to be million kilocalories per hour, or maybe megawatts per hour. Megawatts, not hours, but megawatts. So these are some of the units which are used for heat duty. So let's talk about the the first parameter we need to know, and what is how much heat duty is being transferred. And the duty, it's generally specified by process engineers. Now, there could be the heater could be supplying heat for a reaction. So start of run will be different and end of run will be different, at the catalyst. Similarly, if we have a preheat exchanger train upstream of the heater, there also start of run may be different. When the exchanger train is clean, it will be preheating more. When the exchanger train is fouled, it will be lower inlet temperature. So when you are specifying the heat duty, you need to think about how much margin I'm going to keep. Because you are not going to be building fired heaters every 5-7 years. Most of the fired heaters are built for 50 years. So even though technically the life is 20 years, but there are heaters which are 50, 60, 70 years old still operating. Next thing you want to talk about is the design margin on the flow. Today my crude unit is operating at 50,000 barrels per day. What will happen 3 years from now? Am I going to be increasing my charge rate to 60,000, 70,000 barrels per day? Or what's going to happen? So just think about the margin on the flow, on the temperature. The duty basically is MCP delta T, 3 parameters. So we need to think about charge rate and the temperature difference.